Welcome to the Heat Treat Podcast, sponsored by Matza, Creo, and Super Systems.
Welcome to a new edition of the Heat Treat Podcast. Today we have a great guest, a lot of experience here, and a lot of knowledge. One of the most well-known characters in the industry of heat treat regarding when we talked about vacuum, titanium, or super alloys, Mr. Bob Hill. How's it going, Bob?
How are you, Carlos? Thank you for the very kind introduction. I appreciate that. Good morning.
Good morning to you, Bob. I gotta say, titanium and super alloys are not my base, so I'm really looking forward for this personal masterclass and for you to teach us a little bit about the applications, about the industries, and how titanium and super alloys have evolved during the last 20 years, and we're evolving also as heat treaters and how we're using those metals. So maybe we can start talking about yourself, who you are, the company you represent, and a little background before entering into the technical side of metals.
Great. Thank you, Carlos. Yes, my name is Bob Hill. I'm president of Solar Atmospheres of Western Pennsylvania. And recently, about 2 years ago, we acquired Solar Atmospheres of Michigan. And I'm in charge of that facility also. And I've been in the heat treating world for almost 45 years now. Started out my career, I graduated from college. I was a teacher, quite honestly. And I had this little student teacher who came in my classroom and kind of cute. And turns out she turned out to be my wife of 44 years today, actually.
All right.
And Chris's dad owned a facility in Southampton, Pennsylvania called Precision Heat Treatment. And when I was teaching, we had our summer in the U.S., we have our summers off. And, to make extra money, I didn't make a lot of money teaching then, about $8,000 a year.
So I got to interrupt. Did you teach materials or something related?
No, it was high school.
High school. Okay, got it.
And so we all had extra jobs. We painted houses or whatever in the summertime. Well, when I started dating Chris, her father said, "Well, I need help at Precision Heat Treatment. Why don't you come and help?" And I did that for a couple summers. And turns out that Chris's grandfather, who founded the company, passed away, and her father asked me to come into the business. And at that time, he offered me 3 times more than what I was making working as a teacher, unfortunately, or fortunately. And I decided to go into the heat treating business with her father in 1980. Went to night school to learn metallurgy. Because I wanted to know what was going on inside that furnace. But at the time, we were much like you. We did a lot of integral quench, atmospheric furnace quenching. We did induction hardening, black oxide, flame hardening. And in the back corner, we had this little vacuum furnace. And it wasn't very good piece of equipment. It was new, but didn't really operate well. And we had trouble. We had a lot of vacuum customers, but we had trouble serving them. And at the time, I went to my father-in-law. I said, we should either buy new vacuum furnaces. I believe this is the future of heat treating. And he said, no, we're just going to fix this thing, Band-Aid it together. And that wasn't really the answer. At the same time, about 1983, this little company just about 20 miles north of us, out of an offshoot of vacuum furnace systems, VFS, called Solar Atmospheres, was just starting. Roger Jones, who's a great colleague and great friend of mine, by the way, I hope everybody extends their prayers to Roger. He's not doing very well, and he has some battles ahead of him, and he's been battling cancer for a while, and we wish him all the best.
Or thoughts and prayers to him.
Thank you. Roger's a great friend, and I knew him through ASM. And I said, Roger, you guys have this one vacuum furnace that they were running at the time because somebody from China backed out of the sale of the vacuum furnace. And Roger was running it. His dad said, go ahead and try to make some money in the service arena. And Roger did a great job with that. He started building up the company. And at the time, my vacuum customers were becoming more disgruntled about the color of the parts that we were producing, did not have good leak rates. So basically, I gave Roger my father-in-law wanted me to broker the jobs between Solar and us, and I did refuse to do that because I didn't want to be in the middle of a problem. So we decided to send all of our vacuum work from Precision to Solar, and that actually gave Solar its start. So that whole time, Bill Jones and Roger, over the years, kept calling me up and said, why don't you come work for us? And I said, no, I'm loyal to my father-in-law. I cannot leave. And I probably had about 3 dinners with them over a period of four years. And I finally decided when I turned 40 years old in 1995 that I'm done. I cannot do it anymore with my father-in-law. A lot of reasons why I don't want to get into, but I just wanted to cut loose and see what my next part of my life would bring me.
Sure. The next chapter.
Next chapter. And
which was a long chapter. How many years?
15 years.
It's still a chapter in process, right?
Yeah, right. It was 15 years in the heat treating business. Well, the day I let my father-in-law know that I was leaving, a headhunter called me and wanted me to come to the Midwest. And I did some interviews in the Midwest. And I was ready to move my family to the Midwest. And one Saturday I was cutting my lawn and my wife said, you have a phone call. And it was Bill Jones. And Bill called me and he said, I heard you just heard rumors that you left Precision. And I said, yes, Bill, that's correct. And he said, I want to have you meet me and Roger at our plant that day within the next hour. I said, okay. So I covered with grass. I got in the car. I went up to Solar. It was then VFS building in Souderton, which was only a couple miles from my house. And we sat down and he said, I want you to come work. He said, you're not going to go work in the Midwest. I want you to work for Solar. We need you. And why didn't you call me before? I said, because I turned you down 4 other times and I felt like that was wrong and I wouldn't go back to you. But he appreciated my loyalty to Precision Heat Treatment. But that's how I started. 15 years of precision heat treatment in what I like to classify as the older type of heat treatment. And in 1995, I started with Solar Atmospheres in Souderton as VP of Operations. And that started the genesis of Solar Atmospheres. So I go a long ways back with Bill and Roger when they first started this company.
Solar has become an icon company in the American market. If somebody has gone or has been into an American heat treat show like FNA, right? There's always that big yellow vessel and that sign, and everybody knows that's equal to Solar, right? That has become a benchmark. So now I also understand that you like to do a lot of R&D about different sizes of furnaces. But before getting into the unique features of vacuum furnaces, we're going to talk today about titanium and super alloys, and maybe we can then go to the application itself. Let's start the technical conversation. So when it comes to titanium and super alloys, well, I'm reading this, right? So we know that titanium is a low-density, high-strength metal with excellent corrosion resistance, and it's especially in the marine and chemical environments, right? The properties make titanium ideal for application in the aerospace, military, medical, and automotive industry, right? So that's like the definition I found on ChatGPT about titanium, right? But now, how can we link it to our industry in heat treat? Where does those interconnect, and where the application makes sense? And if you could give us just a little soft landing to the guys like me that are new to these metals.
Well, let's start with titanium, Carlos. Titanium, as you said, is known as the wonder metal. It's as light as aluminum, but yet as strong as steel. Very reactive, however, and that's why vacuum furnaces are most important when treating titanium. If you would heat treat titanium in an open air furnace, it would just absorb hydrogen, and hydrogen embrittles titanium. And that's not a good thing. So you need to have a totally inert atmosphere without any oxygen leakage whatsoever. In fact, when we're treating titanium, we like to see our leak rates. We usually say about 10 microns per hour. We want to see a 0 leak up rate per hour when treating titanium, because it's very, very reactive. It'll absorb any kind of oxygen and form an alpha case, which is also detrimental with titanium. An alpha case layer on titanium is very hard. And if you go to machine that titanium part or component, it will break cutters. And it's not an ideal situation on a surface of a titanium component. So titanium, it's been a metal that's been discovered by Dr. Kroll many years ago. You can go into the whole history of titanium, but titanium ore, when you walk on the beach of the sand, on sand, the beach, that little black speck, that's titanium ore. And there's a real intricate process to get that ore into what's called a sponge phase, and then into a final melt for aerospace grade titanium. And it's very costly. The Kroll process is very costly. You might have seen most recently, there's a lot of companies out there trying to eliminate the Kroll process because it's very energy intensive. There's a lot of chemicals involved in producing titanium. So there's a big emphasis on that. But that's why titanium is kind of like a sexy material. It's very expensive.
Okay, let's touch on the subject of the cost, because cost is it's a major thing in our industry. How expensive is the titanium if you compare it to another metal for a custom application? What's the balance there?
Oh, if you compare,
if you allow me to refer, when is it worth to apply titanium to your application?
Okay, good question. Titanium was in the dumpster back in the 2000s. The titanium companies that were around, they were hurting for work. All of a sudden, titanium got big into golf industry. So there was a big influx of need for titanium. It became, like I said, a sexy alloy. And then what really kicked it into gear is the advent of Boeing 787 Dreamliner. All the time, aluminum could always be used in aircraft, airframes, and component critical parts, heat treated aluminum. However, when they developed this new aircraft called the 787 Dreamliner, they wanted to make an all composite fuselage. So if you ever flew on a 787 Dreamliner, you look down the side of the fuselage, it looks like glass. There's no rivet marks, there's nothing. It's beautiful fuselage. Well, composite is very light, very strong. And however, to have structural metal behind that composite being aluminum, they quickly found out that it forms galvanic corrosion. Anytime aluminum touches composite, corrosion can form. So the only noble metal that can touch composite in a critical aircraft application is titanium. completely noble. So there's no corrosion whatsoever. So when the 787 Dreamliner was developed, they were looking for lighter, more fuel efficient aircraft. And this is the way they could take weight out of the aircraft. So they looked at a lot of titanium. There's more titanium in the fuselage of the 787 Dreamliner than any aircraft Boeing or Airbus has ever built. So that made the demand for titanium to escalate tremendously. So now the titanium mills that were slow, they couldn't make enough titanium in those days in 2007 time period when the Dreamliner was being introduced. So, and as you know, I don't know if you've ever flown on a 787. It's a beautiful aircraft. It's a dual aisle aircraft. They have a lot of features in it with the no window shades, with the chromatic shading of the windows. They have much higher. I'm a tall guy, 6'4". I can walk to a window seat and not duck down. Much higher ceilings. They can, because it's a composite and titanium airframe, they can introduce humidity to the cabin. So you fly internationally, you don't feel wiped out after a 6-7 hour flight. You're dry, your nose is not dry. You have some humidity in the cabin. So that really changed a lot for us in the titanium world. Before the Dreamliner came on board, when I started here in Souderton in 1995, we started doing a lot of 15,000 pound coils, huge coils of commercially pure titanium. And they used those, they would take that coil of sheet and make heat exchangers, titanium heat exchangers, mostly for desalination plants to make fresh water. We would get a 15,000 pound coil here in Souderton. I'm calling you from Souderton right now. But we would load them in our vacuum furnace, a 15,000 pound coil on top of a forklift, bending those forklifts, trying to wiggle a 15,000 pound coil into a vacuum furnace. And we took great risk at doing that.
Yeah, I mean, because I want to talk about the challenges of heat treating titanium being some of those. But before we go to that one, because Boeing, I think there's a lot of merit that Boeing publicly acknowledged solar atmosphere's contribution to the Dreamliner. But can you elaborate a little more on the significance of this achievement and how you collaborate with Boeing? Because I mean, that's a big milestone, and I don't want to just skip it.
Good.
And also, if adding to the question, can you describe the challenges of heat treating titanium that come along with this story?
Sure. Okay. The first challenge that we had with the Dreamliner was treating this new alloy of titanium called 5553, Ti 5553, and treating that to what's known as the BASCA spec, the acronym BASCA for beta anneal slow cool anneal. And we were actually the first customer, we were the first heat treater that was able to heat treat production parts in the aircraft, which were huge forgings, to the BASCA spec. Now, you might say, what's so critical about that? Well, Kevin Pekelja, my vice president of operations, spent day and night. He probably didn't sleep for a whole week trying to figure out, with 15 thermocouples on huge 5,000-6,000 pound forgings, how to control bringing that forging up to a solution treating temperature above the beta transits, about 1750, and then bringing it down to the aging temperature with a slow cool, like 3 to 5 degrees per minute, down to the age temperature, and without overshoot or undershoot. And that was quite a challenge for anybody to do. Yes, you could do that in a small lab furnace somewhere, and people were doing it in small lab furnaces. But a 7,000 pound forging with 15 thermocouples and looking at delta T's between
that might be something similar to the image you're displaying in the back. I mean, the on your TV screen on your back. I mean,
that screen in the back is something to show about the amount of titanium.
Yeah, that's a lot of metal.
Yeah, that's a lot of metal.
That's a lot of metal and money.
That's about 100,000 pounds worth of titanium sheet. But that's another process. That's not what I'm describing here. That forging job, unfortunately, we had many Boeing engineers watching us day and night do this process. And unfortunately, we probably let them in too many times because they learned from us how we did it.
Oh.
And Boeing's great, the way that they form joint ventures around the world. At that time, they formed a joint venture with the largest titanium producer in the world, VSMPO. And
where's it located?
It's in Russia.
Russia, okay, got it.
Sold to Russia. And they formed a machining center. So what Boeing wanted to do, they would buy the big forgings, but they wanted to keep, when they machine, they wanted to keep all the chips where it was so they can revert or recycle the chips. Well, they were making all the chips out of Portland, Oregon, and then they would try to send the chips back to Russia to revert for more forgings. So they decided to form a joint venture with VSMPO. That was around 2007. And unfortunately, we lost that work. VSMPO said, well, little solar atmospheres can do it. We can do it, and we can buy a vacuum furnace from where they got it, our sister company, VFS. They built the furnace for us, and we lost that work. Fortunately, with the problems in Russia right now, a lot of that work has been coming back.
Right.
Typically, titanium, you solution treat and you water quench that and then age. But this alloy was very critical because they needed dimensional stability. So that's when they developed this slow anneal, this slow ramp down right into the aging. And it was properties were much harder than Ti 6Al4V. The typical workhorse of titanium is titanium 6Al4V. So we got involved with this new alloy with Boeing and then eventually VSMPO early on, and we were the only ones able to achieve these properties.
And just gotta ask, how slow is the cool down?
We go with 15 thermocouples, we had to go between 3 and 5 degrees per minute.
And the tolerance is plus minus how much? 5. Okay.
So
that's a lot of mass. Very big loads, a lot of mass.
Yes, but these forgings also had thin sections. So we had a balance between the thin sections and the thicker sections. So we had a lot of playing we had to do. It's something you could never program a furnace for. It's just something that Kevin stood in front of the furnace and worked it out. And, you know, we eventually were able to add some programming to it to make it more repeatable. But basically, we lost that job. But our second trophy, that was our first trophy with Boeing. Our second trophy in 2007, I get a call from Boeing. They're developed a new seat track for the 787 Dreamliner. And the seat track not only holds the seats into the airplane, the floor of the airplane, Carlos, it's also the spine. It's the backbone of the aircraft. That's where all the stress is figured from the aircraft. So when you walk on an aircraft floor, you're walking on a grid. Okay.
Yeah.
And this grid, the stringers going longitudinally long ways in an aircraft are called they called it this pie box seat track. A new design, much stronger than 737 previous designs, 767s, 777 designs. It was actually a fabricated and welded, laser welded box, 33 foot long. So they developed this part, but they had no way, they couldn't figure out a way. Now we have to vacuum stress relieve it. And after the welding, this part, it has a big smile. It's not meeting the tolerances. So we had to find a way to straighten it. So they came to solar. And we went out, we met many meetings out in state of Washington with engineers. And I asked them, what's your idea for fixturing? And he said, well, let me show you. They brought me down to the shop in Auburn, Washington, and they had a seat track, a part of only a 6 foot long seat track that you couldn't even see the part because it was enveloped in Invar 36 fixturing. And I said, well, Invar 36 is very expensive, guys. And I said, that might work for a couple cycles, but after a while, Invar 36 is going to warp. They said, okay, what do you suggest? And we said, the only suggestion we have is graphite.
Graphite, okay.
Graphite is fixturing because titanium, Carlos, is like a big spring. It's very easy to flatten, unlike steels. Steels are hard. You need a lot of weight, a lot of temperature to straighten steels. Titanium, you can take titanium up to only 1,000 degrees, and with a little bit of weight, it'll take the shape. So they said, well, we need a furnace, a vacuum furnace. At the time, we only in Hermitage had 3 24 foot vacuum furnaces. And they said, but these parts we're designing are 32 foot long. We need a bigger vacuum furnace. So I went to Bill, and we already proved out our big 24 footers that were becoming well known in the industry. And I said, Bill, we have a problem. We have this huge opportunity, about $5 million a year, to process, be in the supply chain for what's known as the pie box seat track. And we can do this, but we need a bigger furnace. He said, great, let's build a bigger furnace. Just like that.
Just like that.
Just like that. No long-term agreements, nothing. Just let's do it.
Right.
He's always up for a challenge. So we in the 24 footers, we did some prototypes, and we developed a graphite fixturing system that not only keeps the part, it will keep the part within 60,000, the spec is within 60,000 flat over a 32 foot length. And we were able to do that with precision ground graphite, with standoffs that are precision machined, and we do it with 10 layers of graphite. So in one load in that 36 foot furnace, we can do about an aircraft and a half worth of pie box seat tracks in one load, about 85 parts, lengths. So every load we build up, it's almost like building a pyramid.
Yeah.
Base plate, which has to be precision ground, and then we build upon that. Because when we lay the seat track on, it's like a big smile. So we weight it down with stainless steel weights to get that flatness on the datum A. So it's usable. So basically, we're in the middle of the supply chain. We're getting these parts in that are not usable for the aircraft, and we're making it usable by our vacuum stress relief cycle and creep forming simultaneously. And then in that building, they also said, this is a very complex supply chain. They said, now that you have this figured out, and we figured out all the fixturing for them, and we proved that we could do it. Okay, well now the welds need to be liquid penetrant inspected. I said, okay, well, I was a level 3 inspector many years ago, Magnaflux, not in dye pen, but we can train our people. We can get a cell. So now after they come out of the furnace, we do the dimensional inspection after the vacuum stress relief. They have to be bright and clean. if there's any discolorization at all on there, we have a problem. That furnace has a 0 leak rate, like I said. So they come out looking like jewels, nice and flat, and then we go through a die pen operation on the longitudinal weld. And then most recently, about 5 years ago, they asked us to do some parting, some saw cutting of the part for the next operation up in Montreal, Canada. And so I gladly offer our services for any downstream operations to keep the job at Solar.
And I gotta ask, how do you manage, and more on the business side, how do you manage the experience about them not getting the know-how and implementing it somewhere else, since you developed the fixture and the knowledge of this process, which in the past they just took it away and gave it to another supplier where you did the R&D yourself? Where were some of the logs? I think there's some merit on the business model that you just mentioned. You develop a huge process, very profitable for you guys, and then they just take it away. Because one of the biggest challenge for heat treaters is to buy a furnace specifically for an application, and then when the customer grows a lot of demand, they do it in-house, and you just remain with a very big empty furnace and a huge investment. Is there something you want to add to that?
That's very, very observant, Carlos. That's the way of the world. And yes, I found that we work a job up to about $1 million a year. Guess what? They're going to start looking for their own furnace and bring it in-house. The good part about us at Solar, we have a sister company, Solar Manufacturing, that I can turn them on to, because they're going to buy a furnace anyway. They may as well buy from us. And what we have great value. We will help our furnace builder to show the customer how to do it if they buy a furnace from us. So there's great value. Of course, we never want a customer to buy a furnace and learn from us, but the world's kind of an open place anymore. And I feel like, we can share some information. I'm not worried about it, because there's very few places that will build a 48-foot vacuum furnace or a 36-foot vacuum furnace. And we have the car bottom design, I will say too, Carlos, that car bottom on that furnace you see behind me, that was built for weight. That's 75,000 pounds of sheet, titanium sheet on that thing. That's what we built it for originally. But the C-Track job came along, guess what? Dimensional control was important. Those C-Tracks weigh nothing. You and I could lift a 36-foot long C-Track in one hand and flex it up and down, but there's more weight with the graphite fixturing. But the dimensional control, having that load car, is wonderful. And we kind of learned that after we built the thing. We built it for weight, and then we found out, it's great for weight, but it's also great for dimensional control. We could have never done a 36-foot piece again on a forklift that's bending, and all our tolerances go out. We're on a solid. By the way, Bill has a patent on that load car, U.S. patent on that load car. But on that load car that he designed, it's wonderful. It's a wonderful piece of equipment.
And I got a question about patents now that you brought it up. I mean, you mentioned that you developed so much processes and engineering because you're a vertical integrated company with your manufacturing, which you own the technology and the processes, technology and engineering of the furnace itself. And Solar Atmospheres is the one that developed the process. Why you did not patent the first process you did for Boeing? Or do you patent process? Because I know that there's some big commercial heat treaters, won't say any name, that they own the process. And if somebody wants to heat treat or use their process in their facilities, they had to pay them a fee. Are you familiar with that type of business model? And what do you think about it?
Yes, we are familiar with those companies out there that do that. Bill, you got to know Bill Jones.
Yeah, I know, sharpest guy ever.
Yeah. He's of the opinion that the world is a free place, and we develop things and people will find out about it, and he's not worried about it because there's going to be another opportunity that comes along.
Sure.
So, and I kind of understand what he says, but yeah, when VSMPO wanted to buy a furnace to take $6 million worth of business out of our facility, yeah, I was upset.
Yeah, it's a big hit.
But what are you going to do? I mean, those engineers have to come in. They have to watch what you're doing. You don't think they know what they know what you're doing. They get our charts. They can get data from from the charts that we give them. We have to give them furnace charts. We have to give them certifications. And let's face it, we did not develop the material.
Sure.
They developed the science behind the cooling. We just met those parameters. So there's a lot of give and take, but no, we don't usually, of course, there's some information we keep in-house. A lot of information we keep in-house. We don't give it out freely, but if people find out about it, they find out about it.
So we are deflecting a little bit from titanium and superalloys, and we're talking about a little bit about businesses. But I gotta say, we have met several times, we have several discussions,
Yes.
and you're a very well-known individual also for your leadership and the company culture and teamwork you have created. And I do believe that that's also yes, and it's true, for the commercial heat treaters out there that are listening, can you just share with us what are the principles for maintaining cleanliness in your organization and efficiency in your facilities? I have had the opportunity to visit some of your facilities, and they're state of the art. I can actually tell that you can eat from the floor; they're pretty clean, and that's not. You don't find that much on heat treat shops, and it takes a bunch of culture, teamwork, discipline to have clean facilities, organized facilities when materials are coming in and out. We know that furnaces are in a hard dose environment. We got fumes, we got oils, we got debriefs. Can you tell us how you created that culture? How do you manage that one? How do you delegate that one? Because I do want to repeat, your locations are state of the art, and it's very hard to maintain and to create a culture at that level that you have. I do believe that is worth sharing for us as a community of heat treaters to use your best practices and avoid your failures. If you could just go a little deeper into that, I find that really valuable.
Thank you. Well, I can't take the credit for that. Quite honestly, our process of primarily using vacuum furnaces helps in that endeavor. I came from an old heat treat shop where your shoes would stick to the floor and they're filled with smoke and flames. Came to solar, I felt like I died and went to heaven because it was such a clean environment.
Right.
No smoke. I wasn't ingesting smoke all the time. I wasn't getting third-degree burns on my hands like I did in the past. And I quickly saw when I first started solar, we had one little oil quench furnace that everybody in the shop hated. They didn't like it because it's smoky and everything. And I saw that furnace. I said, let's do some tests with that furnace and some high pressure gas quenching with our, at that time, 6-bar furnace. And it was amazing to me how high pressure gas quenching could meet some of the hardnesses that we're getting out of oil quench. So I saw really quickly a real advantage of gas quenching over liquid quenching. So that helps a lot. When you have inert gas quenching and you don't have the oils, you don't have the salts, you don't have, we had lead pots back at Precision Heat. We don't have any of that anymore. So that helps a lot. Now, what I do with both plants in Western PA and in Michigan, the first thing I do, I give the employee, when somebody starts new, I give the employee a book. It's called 2-Second Lean, and it's written by Paul Akers. And it's a very simple, easily read book. You can read it in one night. Basically, it's housekeeping, general housekeeping rules. And you can apply this not only at work, but at home. And I ask everybody, read this book, and then we get everybody together. And what bothers you? What bugs you at work? And somebody will say, that guy never picks that tool up, or, this guy never, always does this. And, we would list these things down, and we quickly found out, yeah, we need shadow boards. We need shadow boards for every tool that an operator needs. So now we look at our shadow boards, and at every furnace we have a pry bar, we have a cross cutter, we have a screwdriver, everything that they need to make a thermocouple or move a basket on a grid, they have right at each furnace. And it's outlined, so we know right away if that tool is not there. Quite honestly, some operators, it always happens in every shop, every heat treater will tell you this. They leave a flashlight in a vacuum furnace. And then you wonder why
there's always that guy. There's always that guy.
And then you wonder why it doesn't pump down. Well, when load comes out, you find out why it didn't pump down when the melted flashlight's in there and the hot zone's destroyed. So we need a great organization, and I'm a real stickler about that. I'm also a stickler about safety. Without safety, we don't have a business. It doesn't matter how many of these great furnaces we have. If we don't have health and safety protocols in place, and you don't have a business. And I'm quite proud to say at our Western PA facility, we have a thing called SHARP accreditation. And that stands for Safety and Health Achievement Recognition Program. And it's basically, Carlos, we call OSHA in. We want them to come in to see our place. They do an audit. Of course, you're going to have some things that you got to fix, just like any audit. And we did that in Western PA, and we've done that now for about 7 years. And we are one of probably about, I think in the state of Pennsylvania, there's about 90 companies that have this SHARP accreditation. It's only for companies less than 100 employees. For larger companies, they have another thing called, I forget what it's called with OSHA, but for smaller companies, it's called SHARP. And I want every employee to go home at the end of their shift back to their families whole,
safe,
with no injuries. And that's the key to that's the key to my philosophy, because without that, we could do all the great stuff in the world, but if you have accidents, or you have a fatality, or you have something, it really will really hurt the company. Not only hurt people, but I just couldn't live with myself. So we do that. I also would love to, now that we acquired the old VacMet, now Solar Atmospheres of Michigan,
right?
We want to get them SHARP approved. Now I looked at the Michigan website. It's strange, but there's only a few companies in the state of Michigan, maybe like 20, that have SHARP approval. I don't see any heat treater that has SHARP approval in either state. But we're on there for Pennsylvania, and we will be in Michigan. And that's most important, because a clean, organized shop is a safe shop.
It is, and a more productive shop.
More productive, absolutely.
So love what you mentioned. I'm going to buy a right book right away after our podcast. But looking to the future, I do believe that we are in a tipping point. What's your future outlook, and what do you believe will be the industry challenge in the next year? Because we're facing some challenges right now with labor. Every heat treater is facing challenges with labor, and also the industry is evolving. What are your insights on what's coming to our industry in heat treating?
Good question. I go back to my mentor, Bill Jones, in 1970, 75. I was at an ASM meeting, and Bill Jones, somebody asked that exact same question to Bill Jones. At that time, he was president of ABAR, and he said, someday, he pointed at all the heat treaters in the audience. He said, someday, all of you will have vacuum furnaces instead of atmospheric furnaces. That was quite a statement. And I thought, oh, he doesn't know what he's saying. Well, look at 2024. Vacuum furnace industry has really, really made great inroads. I don't know what the balance is. Only the furnace manufacturers can tell you that. But I do foresee the future, more and more vacuum equipment in our heat treating world. Why? I believe there's more and more pressures. Believe, if you want to believe in global warming or not, but we are all getting pressures from our customers. What are you doing to reduce your carbon footprint? We can easily answer that with vacuum processing. We don't have combustibles. We're heating by electricity. We do not have flames. We don't have smoke. The gas quenching is quite environmentally friendly, and it's a great answer to that question for the future. So I really believe, and now we just recently developed our Neo vacuum oil quench furnace, which we might want to talk about. But again, that thing has been in my plant in Western PA in operation for over 2 years. You can eat dinner off that furnace today after 2 years of full operation. Completely benign, no smoke, no flame. You quench a 2,000-pound load in there, you don't even see a whisper of smoke. That to me is the future.
And I gotta ask, me being an atmosphere guy and quenching on oil, why did Solar, being one of the champions of high pressure gas quenching, decided to say, after your comment about where the industry is going, desired and actually took a look and say, we need to build an oil tank. Is that a fair question?
Very fair. During COVID, when our business declined 30%, I went over to Mr. Jones's house. I said, Bill, I would like to develop a vacuum oil quench furnace. There are certain alloys, and I explained to him at the time, yeah, we're doing a lot with high pressure gas quenching, but there are certain alloys that we will never be able to gas quench because the specs do not allow it. They must be oil or water quenched, liquid quenched. And there are certain alloys that we just can't get with high pressure. We've tried 20 bar quenching. We tried 600 horsepower blower motors, gas velocity and pressure. And you just can't get certain properties on certain materials. And that will never change. Not in my lifetime, not in your lifetime. So I said, let's raise the white flag to those alloys and let's go after them, because we needed more diversity, especially in Western PA. So Bill said, that's great, let's do it. Let's get our engineers together and let's do it. And we designed, I said, Bill, with my experience, the biggest challenge in building this furnace is the transfer mechanism. How do you move 2,000 pounds at 1,600 degrees hot metal over to an oil quench tank without buckling, without jamming, without falling into the oil? How do you do that? He said, we have the vacuum down. We know the heating, we know the vacuum, we knew that. I had no fear of that. My fear was the transfer mechanism. So we had weekly meetings with our engineer, and Bill's head into it during COVID and after COVID. And our lead engineer at Solar Manufacturing, Bob Wilson, came up with this transfer mechanism design that is just wonderful. In over 2 years of operation, we have not had one single crash. And you know what crashes are. right?
I do.
Okay. In fact, about a month ago, we had a power outage. I said, what happened? Lights went off, lights went back on. Went outside, somebody said a Canadian goose just flew into the transformer, kicked our power off. I said, that was great. That was when we were just quenching this load out of the Neo. So I went down there, I said, where is the load? We have a camera inside the vestibule. You could see the load over the oil, it's all controlled by hydraulics, by the way, sitting there cooling down. You could see it wasn't 1600 anymore. It might have been 1250, losing color. And typically, if that would happen in the old shop with pneumatics, cylinders would drop, we'd lose air, cylinders would drop. Guess what would happen to the load? The load would jackknife or pulling out, the handler would buckle, all kinds of things happen. I saw that load stopped on a dime. It was cooling. I said, great. Now we have power. Let's back it back up into the furnace. We backed it back up, reheated it, quenched it, zero surface contamination, no decarburization, no carburization. It's just like it never happened. And without a puff of smoke. So that really showed me, I know what the old days were like. And that vacuum oil quench furnace really, to me, is a game changer for the future. Maybe not in my lifetime, Carlos, but in your lifetime, I think it will be.
I would love to see it. I mean, it's been very well marketed on the industry, and to match quench oil tank with Solar's standards of cleanliness, I think it's worth looking at that process.
Yeah,
if I'm around, I'll give you definitely a call.
Oh, you're welcome. If you're in Pittsburgh, you're welcome to. In fact, grab a hold of this month's thermal process. We got the front cover about that furnace.
Oh, okay.
And there's an article in there about that Neo furnace. The other danger that I see.
What does Neo stands for?
Neo is Latin for new.
Okay.
NEO. Okay. That's just it. Okay. We just named it. We needed a moniker for it.
All right, got it.
That's what we did.
Pretty catchy. Neo furnace.
Yeah. The other thing that I see is a danger to our industry.
A danger to our industry. Okay.
You asked me about the future of the industry.
Yeah.
I worry about power, electrical power.
Okay.
And our grid system. That's what I worry about. Not so much labor. We can get over the labor things. I worry about our electrical grid. We see what's going on in California. We see what's going on coming back east now with peak days, and we get in Michigan, we have an interruptible power rate where when they call us and we have to shut down right then and there within 5 minutes, completely dark. That to me is very scary for the future of our industry. We need to have good, sustainable power. And I'm not going to get into the politics of that, but that is a big, big threat for our industry, I believe.
Because we use so much energy, no matter if it's gas or anything.
Exactly.
Yeah. Very well said. Now, just to catch up, it's been great to talk to you about titaniums. Great storytelling about your whole career. I loved it. I learned a lot about it.
Thank you.
When I'm in a little more mature of my career on a different stage, I would like to have such an interesting story as the one you told me.
You will.
But just go to you are it's I can see it from far away that you're a passionate engineer about heat treat, and you're surrounded by people that is passionate about doing this. You mentioned you're a director of operations, didn't sleep through a week, right? When he was developing the process. But I do believe that also one of our challenges is that experienced guys, people that have this passion are retiring the industry at a much higher speed than we're recruiting, and we are training the new generation of engineers. Can you tell us a little bit what inspired you to, besides your wife, right, to pursue your career in metallurgy and heat treatment? And what advice would you give to the guys that are just starting in our industry, maybe in the med lab, maybe in the shop, maybe in the maintenance department, maybe they're furnace engineers? But because right now I do believe that we're facing a lot of movement on a tipping point, but we do need the next generation of Bob Hills that are just graduating college. Anything on that?
Yes, Carlos, I would say that our heat treating world it's changing every minute. So if you want to be making widgets every day in and day out, don't get into heat treating. But if you want to have a different experience every day and learn every day is a different situation. And personally, what I enjoy doing is solving problems. I believe I'm good at solving problems. I'm not the best. I'll tell you, when I can't solve a problem, then I go to Bill Jones. And at 89 years old, he can still solve the problems. But I go to him as last resort. But solving problems are very, very important every day. How do you make this fixture? How do you get the properties on this piece of metal? And it's something that keeps me up a lot. And that's what I enjoy. I enjoy that. So I would say to any engineer coming out of school or high school student who maybe college is not for them, if you want a challenging and career where it changes every single day, get into heat treatment. I do not see, we have the company that we bought in Michigan they were rather old in age, and we needed to get them younger. And we have since hired probably about 6, 7 younger people. To me, a company's like a ball team. You have to have that farm team to keep feeding the players in your company. If you don't have that ball team, that feeder system, you're going to die on the vine. So yes, I always want to have a backup for everybody. And I like to look at the age of people too, to make sure that we have that longevity. So when I'm not here, the company will go forward.
Thanks for sharing that, which was very deep. I do appreciate your time, the nice conversation. And I do learn a lot from the very best myself, but that's why I want to share this with the audience. So, Bob, it's been a pleasure to talk to you, learn a little bit about titanium, their applications, and an amazing story about yourself and the solar atmosphere. Thanks for doing this.